Well, good afternoon, good evening, or good morning, depending where you're joining us from. Welcome back here to the Launchpad and our rare live launch coverage of a China Long March 5B rocket prepping to launch in just over 90 minutes from now. If it's your first time here, welcome. My name's Zach, the founder and host here at the Launchpad, and you're joining us for our live launch coverage of the launch of the second of three modules for China's space station in low Earth orbit. Just over a year ago, we saw them launch their cruise and their space station to orbit, and now they're launching their second module. The Wenchang laboratory module is a modular Chinese space station module launching today on a Long March 5B from the Wenchang Space Launch Center in the Hainan Island in China. If you guys have questions, as always, you can send those to us in the chat. But here at the Launchpad, it's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together, and we're glad to have you here. Now, we're going to run through everything we do know about today's launch live for you guys. We'll answer a few of your questions, and then we'll sit back and relax as we count down towards launch. Conan, right off the bat, so much thank you for that super chat. Really do appreciate it. The Tian module, the Wentian, and I'm sorry if I'm saying that wrong because I probably are, is launching to the Tiangong space station, which is up in low Earth orbit at 370 kilometers or 230 miles at a 41-degree inclination. Today's Long March 5B rocket is not a reusable rocket and will crash into the ocean, and of course the fairings are not reusable as well. This is only the third launch of the Long March 5B variant and only the second module to launch to the Tiangong space station. The laboratory module, which as I said is the second module, will join the space station up in that circular low Earth orbit, being attached with the crew on board. The Wentian, or Quest for the Heavens module, is the first laboratory module that will extend the Tianhe core module that was launched on April 29th, 2021, and will provide a pressurized environment necessary for conducting science experiments in zero-gravity conditions. This module will also be used as a backup for the Tianhe in terms of propulsion, orientation, and navigational systems. The module is 16.6 meters long, or 54 feet, and it has a diameter of 4.2 meters, or 14 feet. So about half of what they're targeting the actual Starship to be. The mass of today's payload is 22,500 kilograms, or just under 50,000 pounds. The airlock of the new laboratory module will serve as the main exit entry point for extravehicular activities, or EVAs, when the construction has been completed. The node cabin in the module will serve now as a backup, but that's what they've been using currently. This module is powered by two 30-meter steerable solar panels that use photovoltaic cells and will significantly expand the power capabilities of the entire space station. Following docking, it will take its first place at the cargo spacecraft port, which recently separated from the station, and will dock to the forward port of the station. It'll carry a robotic arm that resembles the one used on the Mir space station and will take care of moving the module from the forward port to the planned radial port location. Once docked, the module will be entered by the Shenzhou 14 crew, who will activate the life support systems and prepare the module for upcoming experiments. The experiment cabinets will be used to conduct research on space life sciences, like the current module is. The laboratory module is equipped with living facilities for the taikonauts, including 3 sleeping areas, a toilet, and a kitchen. When the Venetian joins the station, it will be able to accommodate now 6 people, meaning the crews will be able to change directly in orbit, and the station will be continuously habitable from now on. And China does plan on launching a second crew up to the station later this year, beginning their consistent coverage of having Chinese taikonauts in low Earth orbit. If you're just joining us, though, welcome here to the Launchpad. You're looking at a live view of China for the rare live launch coverage of a Long March 5B rocket with the Wentian module launching up to the Chinese space station. At this point, we're at an estimated about T-minus 1 hour, 30 minutes and counting for today's flight. Aravail has a question in the chat. Will this make Tiangong only the third modular space station in history? I believe that would be correct, Aravail. I would have to verify that, but I believe that would be correct. Justin, thanks so much for that 4-month membership there. What's the space station for? Strictly China, question mark. So right now it is specifically China, but China is working on agreements with possibly other countries to be able to do research on board. At this time, there's no plans to have visiting crew members launch to the station, but it is something they are considering in the future. I believe there are a few countries that have some science, though, that will be on board. But great question. If you're just joining us and have a question, you can send those to us in the chat by tagging us at the Launchpad, and we'll be answering that. I know Conan sent in a question. Why is it called the Long March? That's just the name of the rocket. Why is it called Falcon? That's just the name that it is here. And that's exactly what I was thinking, Airvale. Mir and the ISS are the only two that I can think of that are modular as well. If you're just joining us, though, take a moment, engage that like button, share out the broadcast. It really does help us out. And not to point to it, but in the pinned comment, we do have a link there to our GoFundMe. The entire TLP team is headed to Florida, bringing you guys full live launch coverage of Artemis 1. We're super excited to be invited by NASA for this launch, and I'm going to be heading down almost a week before launch for some pre-launch events and full coverage of all 3 launch opportunities. We've got a bunch of activities already planned. We can't wait to share with you, but we need your guys' help. Only getting a few weeks notice means things are a bit more expensive, and we could use your guys' help in the GoFundMe. So take a moment, check that out if you can, or consider becoming a TLP member on Patreon. Never expect the financial support, but it is greatly appreciated to help us expand our team to possibly China, to Europe, and to bring you the best possible coverage of Starbase, Florida, and Vandenberg as well. But as we come down to T-minus 1 hour, 28 minutes and counting, we're going to take a little bit of a commentary break. I see a couple last questions, so we'll answer those, and then we'll be back as we count down towards today's launch. Conan's asking, how many times has this rocket launched? This is only the 3rd time we have seen a launch of the Long March 5B variant of the rocket, so that's what we are expecting to see today. It had successful flights in the past, so we hope to see another successful flight launching that new module up to the Chinese space station. Here at the Launchpad, it's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together, and that's why we do bring you full live coverage of all the agencies around the world. We do wish China well with their space station, because any science is good science, and hopefully that will advance humanity forward for today. But the Taikonauts are up on the station waiting for this new module to arrive. But we're going to take a quick commentary break, and I'll be back in a little bit with another update. Stay with us right here on the Launchpad as we count down to launch of the Long March 5B from China.
Here at the Beijing Control Center, we are thousands of miles away from. But it is the same way here with professionals, experts across the systems. They've been prepping for this mission for weeks, and today everyone has their eyes trained on the launch on the rocket module combination. Now, we've been hearing updates from the flight control team, and throughout the morning, they've actually been telling us the same message that everyone and everything are ready. They are ready for the launch. One of the mission chief for the space application system actually told us that they have 629 troubleshooting solutions for the space application system alone. So they're not going to miss anything. They're not going to let anything happen without any of their forecasts. Of course, as you said earlier, the Shenzhou 14 taikonauts, they will be the first Shenzhou crew to enter into Wentian, and we've also got updates from them as well. The 3 taikonauts, they have been anticipating for this mission, and for the last week, they've been rehearsing different scenarios, and they are ready too. Now, of course, the Shenzhou 14 crew, they would be experiencing so many first-time attempts with Wentian there. Of course, Wentian is going to make their life much more interesting, much more challenging, and their life much more comfortable. Actually, Wentian is a roomier existence. They are going to expand their living area, and the taikonauts, they are going to conduct spacewalk from out of Wentian. They are also going to give lessons from Wentian mission, but perhaps we're getting ahead of ourselves there today. For now, everyone is waiting for the launch. Back to you, Jiayang.
Thank you so much. That's Sun Ye at the Beijing Aerospace Command Center there. Well, gentlemen, we were seeing from the pictures there with our reporter in Wenchang, it's very clear, it's very blue. So this is Hainan Island that we've chosen for the launch site, and China has another main launch site as well. So, but why is this particular location chosen, Professor Sui?
Yeah. As we know, we have several sites that we can launch those satellites or rockets. But Hainan, the Wenchang site, is very particular because it's very close to the seashore. And for this time, we have the Tiangong 5B, which is a very large rocket, right. And this rocket is very hard to be transported to inland areas. For example, our inland Jiuquan or other sites. Yeah, so we have very large parameter. If I remember correctly, it's over 5 meters diameter for this, right?
Yeah. So what about the conditions that's necessary for the launch then in Hainan?
Yeah, I think today we see from the on-site video that the air condition is very good. Yes, we have good winding condition. There are no storms or no other, say, weather conditions. So far, so good.
All right.
Well, I think Hainan Island is chosen because of the particular location. As you know, we have already 4 launching sites. One in Jiuquan, one in Xichang, and one in Taiyuan. So the number 4 location in Wenchang is chosen for its drop zones for safety reasons and also for latitude.
The drop zone meaning?
Meaning if you launch, you have the booster separations, you have the first stage, they're all dropping. So this time if you launch towards the ocean, they're dropping into the ocean without hazardous to human bodies and inhabitants. And also for another reason is that latitude, it's closer to the equator, so the rocket is more efficient, in particular when you're launching to a geostationary orbit.
So it saves more energy for the rocket itself.
Exactly. So they're planning to have extension of the launch site, including commercial sectors and also the future heavy launch vehicles into Jiuquan, in the same location.
Fascinating. Well, let's look a little bit more at the Wentian Space Lab module. It is a giant structure, and carrying it to the China Space Station is, of course, no easy feat. So Sun Ye is again here with this story on how this heavy-duty mission will be carried out.
Both the Tianhe Core module and the Wentian Space Lab module weigh over 20 tons and are at least as tall as a 6-story building. And to take them to orbit as planned,
only Long March 5B carrier rocket can do this. The rocket itself is 53 meters tall with a lift-off thrust of 1,000 plus tons. It's capable of sending 25 tons to low Earth orbit. In short, it's China's most powerful rocket.
那么经过这2次发射任务呢，实际上对于火箭的整个的技术方案。
The entire technical plan of the Long March 5B carrier rocket has been thoroughly tested since the 2 launch missions before 2022. Now it's time for the application stage, and we're confident that the technical state of the rocket is fully developed and stable, and is ready to conduct the China Space Station module launches. This year, we'll complete the launches of the Long March 5B Y3 and Y4, and at the same time improve their reliability and stability to best serve the needs of Wentian and Mengtian.
For Wentian, which has a rendezvous mission, the rocket launch needs to be ever more advanced.
是对于交会对接任务。
To meet the rendezvous requirement, the Long March 5B carrier rocket employed a deviation correction technology at taking off. That extended the launch window to over 2 minutes. We're ready for all kinds of risks on the ground that could delay their launch, and took corresponding measures so that everything on the ground is stable and dependable.
Experts say the Long March 5B carrier rocket will maintain its reliable and stable performance as the designated driver for China's space station modules. Sun Ye, CGTN, Beijing.
All right, so we're just waiting for the launch now. Let's go back to our guests. Mr. Xu, so can you explain to us this zero launch window that we had heard earlier from our reporter there?
Yes, as you know, that the Chinese space station and any other space objects are orbiting in the latitude and inclination in a certain way and certain speed. So this requires the Wentian to catch up with the station at a precise location where it can rendezvous and dock with the station. So this requires a very precise launching opportunity or launching window. So considering the orbit of the Tiangong station, and also considering the launching factors, velocities, altitude, and proportions, the precision launching is very important, so that the 2 spacecraft can rendezvous at the exact location at the exact timing. So if you launch delayed or even earlier, you have to consume fuels on the spacecraft to catch up and to slow down, so that these can have a rendezvous and docking. So precise launching can save fuels and also can save a lot of ground crew efforts, as there is also a TT&C team that is on the ground that's supporting the whole mission, including ground stations on the mainland and also on the ocean.
But that precision is down to the second, literally. We're talking about when we say zero launch window, 0 second launch window. So that 1 second or a few seconds could make that much difference.
Exactly. Considering the velocity and also the altitude of the spacecraft, a small initial mistake can have a huge amplification at the ending. So there is a very precise window that we can launch the spacecraft to have the optimum opportunity for the rendezvous.
Wow, so that really is rocket science there. So we're actually looking at live pictures now from the Wenchang launch site, so we can see the rocket right there. So that is the Long March 5B rocket, so that is a slight deviation on the original Long March 5 series, right? Professor Sui, so this rocket has a nickname that science fans have given it, which is Pangwu, which means chubby 5, right? And I think it's quite apparent from its looks. It is slightly wider in width, perhaps, with other rockets. But is it designed this way for a reason?
Yes, it is. Yeah, so this we call it chubby 5 or Pangwu because the aspect ratio of this rocket. So the very common rockets we previously seen that they are very narrow, so it's relatively easy to control. But this chubby 5 or the Tiangong 5B is actually pretty wide because we need to design it this way so that it can carry the important large cabins we want to send to the space.
So this is, I think it's considered a heavy lift launch vehicle, and there's another class on top of this, right? The super heavy lift vehicles. What's its payload then?
Yeah, the payload is about I think is about 2510, right?
Yeah, 25 metric
25
tons.
tons.
Yeah,
Okay.
2510.
And then put that in context for us in terms of the Wentian Space Lab, then how heavy, what's the weight of that, and how many, one module, could it potentially carry more than that?
The one module is about 22 metric tons.
Okay.
So that leaves some room for the launching also. But the weight is not the only issue. The size also, the 16 meter long. So you can see the Long March 5. It's a single stage. What we call single stage with strip down boosters. So we have a 4 strap down booster with the liquid kerosene, liquid oxygen as fuels. So each engine has 120 tons of thrust. And also the core engine, which is FY77, liquid oxygen, liquid hydrogen, so cryogenic engine. So all of these combined can put this payload into orbit. As you know that we have already had the Wentian launched into orbit, and also a previous testing launch was conducted. So all of these are successful, but as you know that the last segment or the core segment, once it's entered into the orbit, it also work as a spacecraft. So we'll have to bring it back safely and in a controlled manner. So one of the first missions was unable to do that, but later on we improved our technologies, and so these, what we call the passivation of the last stage has been conducted. So we can safely bring back the last fuselage and safely burn it into atmosphere and drop it to a no habited region.
And do you think the current Long March 5B rocket, the Long March 5 series, is sufficient for China's future needs in terms of future space launches?
Well, this is an interesting question. I think previously we had we called 3.35 meter diameter, this including from Long March 1 all the way to Long March 4. This is for the railway transport purpose. So the railway tunnel is maximum size is only for 3.35 meters. So all of those previous missions or previous launch vehicles were 3.35 meter diameter. So this 5 meter diameter, as Professor have mentioned, are manufactured in Tianjin and shipped to Hainan. So for this larger diameter, enabled us to have a larger payloads, including the Tiangong and Wentian and also future Mengtians, were all based on the 5 meter diameter missions. And also 5 meter also was designed for the lunar mission and also for Mars mission. The Tianwen was also designed in that manner. As you mentioned, there is a future designing which is up to 10 meter diameter.
10 meters.
So 10 meter diameter, what we call Long March 9, will be designed and manufactured in the coming decade. So we hope to have a first launch in 2030, also in the same location in Hainan. So as you can also see that the launch fuels are also different. The Long March 1 and Long March 5 is using UDMH and nitrogen tetroxide, which are highly toxic to humans. So when we move to Hainan, we use kerosene and oxygen only. So these are what we call environmental friendly fuels and also good for the environment. And there's no UDMH and nitrogen tetroxide, which is very dangerous to the environment.
Right. Well, we're now in the 30-minute countdown preparation window now. So 30 minutes to go until launch. So, you mentioned several rockets there. So China has a huge series of lots of long marches, right? So 12 in total at the moment,
I think
is it?
Up to 15
Up to 15
moment,
now.
Yeah.
So obviously that's a lot to go through. So just if you could, Professor, so if you could just pick out a few that you think are very notable in terms of its design and its usage and how that compares to the Long March 5 that we're seeing here, or Mr.
Well, I
Xu.
think the first 4 families, were the Long March 1 all the way to Long March 4, was designed, you can see Long March 2B or 2D is for low Earth orbit, and Long March 2F is for what we call human-rated missions. So Long March 2F has been designed for the Shenzhou missions. All of the Shenzhou has been launched by Long March 2F. And also Long March 3 series, starting with the payloads for geostationary orbit, And also the 3Bs and three varieties are for geostationary telecommunication satellites missions, and also for some of the lunar missions we're using Long March 3 series. Long March 4 is for sun synchronous orbit. So all of these four old, what we call it, old models are using the conventional fuel, UDMH and nitrogen tetroxide. And then starting from Long March 5, Long March 6, and Long March 7, we're using liquid kerosene and oxygen as fuel. Long March 5 is the largest one for launching heavy missions and also lunar missions. You can also see that we launched Tiangong mission on the Mars mission, also based on Long March 5. So Long March 5 is a 5-meter diameter. So when the team start to design the mission, they have a concept of 5-meter diameter, not 3.35. So the design phase started off with Long March 5. And Long March 6 and 7 are for cargo missions, and also for like the Tiangong cargo mission, supplying the station, also using the new generation launch vehicle. So you can see that we have a launch pad of Long March 5 and Long March 7 at the same location. So even they're exiting from the same factory, and also the fueling system is same, so that we can fuel them with the kerosene and oxygen at the same time, and also with the same equipment and facilities. So this is the difference between the new generation launch vehicle and the old ones.
And what could the future next generation of rockets? You said, I think Long March 9, right? You said that would have a 10-meter diameter. What kind of a potential payload could that have?
Well, the heavy lifting launch vehicle has always been used for interplanetary missions. We have a Saturn rocket that is from the NASA in the 1950s and 60s, putting Apollo missions to the moon. The Saturn is relatively the same size as the Long March 9. And also we have, the US is developing SLS launch vehicle, also with 100 metric tons of launching capability. That is also aimed at building a space station around the lunar circle. So size lunar missions and also lunar landing missions would require heavy lifting launch vehicles. And also we have a mission of designing a new generation human capsule missions. So to enlarge from the current Shenzhou size, we're enlarging that to a larger crew members, so that we have also size lunar missions and even more ambitious programs.
Mr. Xu, you did mention earlier that there's no second stage for the 5B rocket. Why is that important?
Well, this Long March 5 has been used for, the most part has been used for containing the Wentian segment, which is over 16 meters long. So we have a large fairing atop of the core stage. And also considering
Sorry, let's just explain to our viewers. The fairing, by that we just refer to the casing that's protecting the main, the module, right?
Yeah, exactly. Yeah. Starting from the last segment of the engine all the way to the top of the payload, or what we call a payload, is this time is the Wentian segment. And also considering the altitude of the mission, the capability of the Long March 5B is able to launch such a payload in low Earth orbit with a single stage. So the altitude of the station is about below 400 kilometers. So it's not very high. So this is going to be a direct injection into the orbit without apogee and perigee changings. So this will have a very good precise insertion of the segment into the orbit. So for precision purpose and also for simplification of the mission. If you have more stages, you have more risks.
Stages essentially meaning, in layman terms, just parts of the rocket, right?
Stages means like once you have complete one segment, the second segment will start burning. So that's the second stage, yes.
Well, earlier we were seeing on screen that the engineers are now doing the second comprehensive check before launch. So these rockets, also Mr. Xu, you mentioned about the propellants that's been used here and how it's much more cleaner and also more economical. Is this something that we could be seeing in the future for all the generations of Chinese rockets, or do you think the kind of the more traditional fuel will also still be needed for?
Well, the traditional fuel has its advantages. It starts to combust once the two segments are met. You don't have to ignite it. So this is the advantage. And also for safety reasons, we have a very reliable system that has been working more than 400 times. So we have this, what we call human-rated spacecraft is based on the conventional fuel. So we're testing and also have more launchings of the Long March 5 and Long March 6 and 7 and even 8. And then we have more accumulated knowledge of the liquid kerosene and oxygen, including oxygen and hydrogen fuels. So we have more experience, we know the reliability of the launch vehicle, then we can improve that to human-rated launch vehicle.
Professor Sui, so if we are looking at the big picture of the space station, and it's currently in this in-orbit construction stage, and you know, we've seen there's 11 missions planned for completing the space station overall, right? So what for you do you think are the most critical or challenging? They're all important in their own way.
Right, they're all important, but from my point of view, so the current one is a very, very unique one, because this is the first time that we have the astronauts, or we call taikonauts, in the space, and they're waiting for the this Wentian cabin. For all the previous tasks, we have there are no men in the space as we stand and we do the rendezvous and docking system. But this time we have human beings in the space. So that means we need to protect their safety. We need to make sure that this mission is 100% safe. Yeah, it's totally error-free. Yeah, and on the other hand, since we know that China has already developed the autonomous rendezvous and docking methods by the help of artificial intelligence and other mechanical advantages in our technology, so a lot of the process, the difficult process, will be done automatically. But if there are some unexpected things happen, we have the taikonauts in the space that they can take over and do the task by themselves.
And presumably this is something they've already trained and practiced for in case they do need to take over manually.
Right. So here so China has this special agency for the training, not only mechanical training but also scientific training for astronauts. So all the astronauts, they went through very difficult training courses to make sure that they can have the job done.
Yeah, I mean, you said this is going to be an automatic docking, but at the same time, the astronauts, they have to prepare in some ways, right? What kind of preparation would they be doing, waiting for the arrival of this?
Right. So actually, before we launch them to the space, the current 3 astronauts, say on the ground in their training stations, they actually need to train the whole process by themselves, the whole rendezvous and docking process, using the simulators and using the large equipments on Earth. And then when they're standing in the current space station, they're just waiting for the new cabin to arrive.
So that's getting prepared in case they do need to take over. But right now, I mean, what do you imagine that they're doing up there right now in the space station?
Well, I think from launching until the moment of rendezvous and docking will take a few hours. And also, rendezvous and docking is prepared and controlled by the ground crew. So basically, they don't have to put their hands on the computer or the sticks and
to
to
control
control
relax.
it. Yeah, they're basically sit back and relax, but they're prepared for emergency situations in case they don't have a successful rendezvous docking. They will have secondary plans and to come up with the contingency plan how to do that in the real situation.
And this we're hearing a countdown there. On the clock it's showing as 18 minutes, 55 seconds left until launch.
Yes, one of the advantage of the Chinese station is that in comparison with the International Space Station, which made different segments in different countries, the Chinese space station was able to have a pre-assemble on the ground, even before the launch of the core module. So that was all conducted in Tianjin when they exit the factory. Before they exit the factory, they had all the stations connected together and to make a complete testings and the functioning of the whole system before they dismantle them and put them into ship and to Hainan.
So I mean, this whole plan for the space station, if it's on schedule, it will be completed by the end of this year. So altogether, it would have taken less than 2 years to complete. What do you think of this speed? Is this very fast?
This is
compared to say, yeah?
This is the fastest in the world. They say we have the Chinese space program have a very fast 0 to 60. So we have very good accelerations, and but also the thing is that we need to have a more advanced system in terms of applications. Even the station, we build the station not for just to build it, but we build it for scientific purpose. So what are some of the scientific experiments which we should put on to the station, and that should not have a duplication with the international station, but also have a creativities and also innovativeness. So how to operate the station and how to use the station is more important in the coming. So after and particularly beyond 2022 when we complete it.
But that's something you're talking about. Keeping some of the projects separately, keeping the experiments and functions separately. I mean, that will take a lot of coordination between the different space agencies, and this is something that, do you foresee any challenges in that?
Well, in China, what we do it this way, we use the Chinese Academy of Sciences. They have an institute for space science purpose. So that institute is established for this mission in particular. And also we have opened this platform to the international community through the United Nations Office for Outer Space Affairs. So they have an office, and they use the UN COPIUS, which will have more than 80 countries as member of the committee. So they can contribute and nominate the proposals and projects, and we can put it on to the Chinese station for flight. The initial stage, we have selected 9 payloads already. So we're in the second stage of selecting new proposals.
What are some of the criteria for selecting these proposals?
Yeah, I think initially we received over 40 proposals, and it's throughout the world, and it's a very challenging process to pick 9 of them. Yeah, I think it's very. I think the first criteria is the quality scientifically, whether those tasks can only be done in the space or they can also be achieved on Earth, right? So if those experiments can also be done on Earth, there's no reason for us to spend that effort to put it in the space.
Right.
Yeah.
Good morning, good afternoon, or good evening. Welcome here to the launch pad.
15分钟准备，调度至风波，景山，华山。110，脱落整流罩空调连接器。
Right when we go to give an update, we get some comms there. Good morning, good afternoon, or good evening, depending where you're joining us from. Welcome here to the launch pad. You can see there some umbilicals starting to be retracted from today's Long March 5B rocket as we count down T-minus 14 minutes, 20 seconds, and counting until liftoff of the second of 3 modules for the Chinese Tiangong space station. If you're first time here, welcome here to the Launchpad. My name's Zach. I'm the founder and host here at TLP. Here at the Launchpad, it's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together, and you're joining us for our live launch coverage of tonight's Wentian module launching from China on a Long March 5B. Only the 3rd time in history a Long March 5B has launched, and this is a live view of LC-1 at the Wenchang Space Launch Center in the Hainan Island area of China. The Long March 5B CZ-5B rocket is being launched by the China Aerospace Science and Technology Corporation, or CASC, for the China Academy of Launch Vehicle Technology, the CALT, who are doing the space station. The Long March vehicle is not a reusable vehicle, so the core stage will come back down to Earth. The boosters will crash into the ocean, and we're excited to see another launch here. A rare time to see a Chinese launch live, but because it's one of their modules, they're giving some pretty good live coverage, and we're glad to have you here. If you guys have questions, you can send those to us in the chat by tagging us at the Launchpad. We'll be answering those live to our best of our ability as we count down T-minus 13 minutes and counting till liftoff. If you haven't yet, take a moment, engage that like button. Let's see if we can get that up there at maybe 250 before launch, and share out the broadcast. It's pretty rare to have one of these launches, and we're glad to have you all here today. You can see there a live view of the countdown clock for Mission Control. We keep syncing ours to there, and live views inside Mission Control as teams count down the final minutes until launch of the second module of the Chinese space station.
各号注意，10分钟，准备。10分钟，准备。
And T-minus 10 minutes and counting until liftoff of the CASC's Long March 5B rocket with the Wentian module heading up to the Chinese space station.
Mimbai. 明白。
Station is even bigger, yeah, and it will play a critical role for manufacturing the space station. Because we know that we're building a very complex space station, although we have those great tycoonists that they can leave the cabin to do the job, but we still want to protect them as much as possible. Yeah, so a lot of work will be done by those robot arm. The big robot arm already in the core cabin, and together with this more robot arm, they will cooperate and collaborate together for the manufacturing for the building of the space station.
I understand they can also help each other, right? Like
Yes,
fix
they have
any
an
problems.
adapter
Exactly.
that they can
Yeah.
use.
It's
They
good
can
friends.
even connect to each other. Yes.
Yeah.
Very exciting. So we're looking at these live pictures now from Wenchang, the launch site. So this is the viewing area. Lots of people gathered there. So when the rocket lifts off, when it actually leaves the launch pad, so I had read before with in the US with the Kennedy Space Center, you know, people can feel the shaking of the ground and feel the vibrations from a couple of kilometers away, right?
You can feel on your chest the
Wow.
vibration of the engine. In particular, this is a larger engine with a total of, I think, 8 working engines at the same time. So each strap-on booster with 2 engines. Each engine has 120 tons of thrust. So you can imagine the amount of proportions and vibration they can create. So it very much depends on the distance that you're standing to the launch pad. The minimum safety is beyond 2 kilometers. But so no closer than 2 kilometers can you. So you have to either hide in a bunker
Right.
or you stay beyond 2 kilometers.
So I think there's the crowds. That's
So the
waiting to
crowd
see
is
this
about
here.
8 kilometers away
kilometers.
from the launch
And
pad.
they would still feel it there.
They will still feel it. They will still feel the vibration and hear very loud. It's like a huge firework.
Wow, so that's an exciting moment that they're in for. And I also read that this rocket, when it was moved to the launch pad from where it was assembled and stored, this was maybe a 2 kilometer distance, but it took it 2 hours to reach there. I mean, that is an incredibly slow speed for what this rocket can manage, right, when it actually lifts off.
It's actually walking speed. I mean, I've been following once with this transport of what we call vertical assembly and EIT center into the launch pad. So that the slow motion is for the safety purpose because it's very tall. It's over 50 meters, and also it is not fueled, so it's not very heavy. So when you pull it to the launch pad, it's relatively lightweight. So with only the weight of the engine and the casing. So once it's on the launch pad, you have to fuel it, and once fueled, it's very, very heavy.
So we've got the 6-minute countdown now. 6 minutes to go until launch. So with this rocket, you said it's vertically assembled. Would the other option not be an option then? To horizontally assemble it and then try to lift it up, right?
It was horizontally transported.
Okay.
So the purpose for vertical assemble is because the launching status is vertical. So everything is on the vertical status. So when you launch it, it's the same status. But if you assembled in horizontal position, when you put them up, some of the things or small things might change their positions, their connections, or even electronically and mechanically. So vertically assembled and vertically launching is the trend in Europe and in China and US.
Why make things more difficult for yourself, right? So 5 minutes countdown now.
5 minutes.
5 minutes to go.
Are we keep fueling at this moment?
I think 5 minutes we're only fueling the hydrogen, and the other oxygens and kerosene. Kerosene has been already, because it's not cryologic, so it's not cold fuels. So kerosene is normal temperature.
Yeah.
Oxygen has been filled until 7 minutes. 7 minutes to the launch. So 4 minutes or 5 minutes to the launch, we'll stop the hydrogen fueling. So everything is stopped and disconnected, and then we have the unlocking of the launch vehicle.
And is that something that would have happened already, the disconnecting of all the propellant?
Yes, I think it's disconnected already. So, but
Right.
some of the last electronic segments and also signal transmission and also electricities are still connected until the last minute or last second even.
Right.
Yep.
And earlier we saw pictures of Chinese leaders waiting to watch the launch as well. And there's
So you see, it's very close to the launching time. So everything is working based on the battery on board. So the battery has its own maximum capabilities. So they have to work all the way until the separation of the fairing. So it's up to the battery to work until that moment. And then before the solar panel is deployed, we'll have to maintain electronically charged vehicle so that we can have signal coming back, and also we can have control of the spacecraft. So it's very important that we have electricity on board.
Mr. Xu, you were explaining to me earlier about the propellant that's used for the 5B, so the strap-on boosters, right? You call them. So
Yeah.
that's hydrogen, liquid hydrogen, and liquid oxygen.
No, the strap-on is kerosene and oxygen.
And then the
core is the hydrogen.
And if you're just joining us, welcome here to the launch pad. You're joining at a great time as we are at T-minus 2 minutes, 40 seconds and counting until the launch of China's Long March 5B, launching their second of 3 space station modules to their brand new space station. If you haven't yet, take a moment, engage that like button, share out the broadcast, and as always here at the launch pad, it's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together, and we invite you to engage that subscribe button so you never miss another live launch coverage, space news update, space briefing, or exclusive one-on-one interview. Let's see, as always, a go, no go in the chat, and let's listen in from T-minus 2 minutes and counting to mission control as China launches their new space station module.
Including the launch site and also the ocean-going boats that can receive signals. So they have to transmit the signals back, and also for the rockets and also for the Wentian segment. And also we're using the global system of Tianlian to have communications with the station, so that the communications and are constant throughout this whole process.
Right. Well, I mean, when we watched some of the earlier launches before, with in particular the Shenzhou missions, you would hear all the different monitoring posts checking in with the main command center to say that or that the rocket is on track.
Yes, there are
the
different
right
tracking
trajectory.
systems, also including optical, infrared, and TT&C tracking system. All of these are functioning well, including at the launch site and also on other locations where the ground stations exist.
So 1 minute to go now till launch.
4号注意，1分钟准备，1分钟准备，120接通，允许点火。
1 minute to go. And we've seen so many so many missions being launched this past year or so. And is this some kind of frequency that you think we'd expect to see carried on for the future of China's space mission?
At least for a couple of years, yes. And also depends on the future programs of interplanetary missions. And also we see a booming private sector that are also launching launch vehicles by
30
themselves.
seconds to go. So even though there's no crew here, it's not as nerve-wracking as crewed missions, but you can still sense the tension here.
Yeah, we'll have a huge blast off with also lots of water cooling down. So this is the final countdown.
6、5、4、
3,
3、
2, 1.
点火，点火。
So there's a time difference between ignition and ignition itself.
140两两分32秒负500毫秒，140两两分32秒负500毫秒。
So people on the beach can see it.
Yeah, that's very visible from 8 kilometers away.
8 kilometers.
程序转弯。
So you can see how large the rocket is. Yeah, even from 8 kilometers
文昌
away,
光学
so
雷
you
达
see
正
the
常，
sound.
摇炮信号正常，文昌飞行正常。
We just had the announcement there that everything is as expected and
110跟踪正常。
So when can we expect the booster to start dropping off to be jettisoned?
Well, that's a couple of minutes into
now.
it before.
317
We're
跟踪
looking
正
at
常
this。is the view from the camera that's on
文昌
the
光学雷达跟
rocket.
踪正常，摇炮信号正常，文昌
Saying
飞
goodbye
行
to
正常
Earth.。
So this is the camera that is facing down. You can even
See
see
the Earth from there.
the
that's
whole
right.
island of Hainan.
阵地112跟踪正常。
So this is the optical tracking system that is monitoring the launch vehicle itself. Maybe the first minute they can still see it.
And from what we're hearing, everything is as planned.
It's nominal.
Going well.
You know the crowd that they on the beach. There's a hotel called Luneng Hotel. Every time there's a launch, it's fully booked.
I imagine so.
In the hotel rooms, you can see the same view on the facing the south side.
Yeah, I mean, it must be an entirely different experience, seeing it on TV like this, but being there and actually feeling the launch.
In your room, holding a champagne.
And not just seeing, but also feeling it happen.
Yes, the vibration and the acoustic feeling.
We're hearing more, these are different stations checking in and...
On the left side is the
trajectory.
optical, on the right side is the simulation. So that we can see very soon the separation of the boosters. So from the optical, it will be very, very clearly. So this is the infrared, I think, the infrared tracking system.
So the jettison of the boosters should happen any minute now.
So we have the optical, we also have the radar system, right?
And if you're just tuning in, we're watching the launch of China's Wentian Space Lab, and that's headed for China's space station.
So the
We're
camera
docking in a few hours, right?
But the fast docking is 6 hours.
6 hours.
6 hours is for the fast docking for the astronauts. But this Wentian maybe takes longer.
Okay.
This is the separation of the booster.
That's right, so that's the boosters dropping off.
So you can see the 4 boosters.
And these would just, most in all likelihood, just drop into the sea.
Yeah, they're in the Pacific. Yes.
And what will happen to them? Will they get them recollected and...
No, normally we just abandon them. This we call it expendable launch vehicle. So
just abandoned, but left to float in just wherever the waves
might
take them?
Drop to the ocean bed, and also maybe good for the coral.
And I guess that's why it's so important that this propellant that it uses is clean, right?
Right. So there's no worry for the sea pollution.
That's right, yeah. And that's the
ferry. So now the Wentian is exposed to space environment. So the altitude is more than 110 kilometers. So there's no atmosphere at this moment. So the core engine will continue to push the Wentian towards the designated orbit. So you can see that the camera is on board the Wentian, I think.
Mm-hmm. So now all that's left is literally, we're looking at the payload, which is the lab module itself, and then the first stage, right?
Yeah, and whether that's a moon, I'm not sure.
And when will the first stage separation happen? Would that be quite soon?
That would be around 8 minutes.
What is the timing that's chosen for the first stage separation? I mean, it's when the rocket reaches. Is there a particular time?
There's I think 2 reasons. One is the velocity of the launch vehicle, and another is the fuel on board the strap-on booster is burned out. So the strap-on booster do not have a fuel belt connected to the core stage. The core stage is only for hydrogen and oxygen. So strap-on booster with its own fuel and own engines burns out and complete.
That's why it separates.
That will have separations. Yes.
And what about the first stage and the payload separation then in this case?
That's very much depends on the orbit itself. It has to be inserted to 397 kilometers altitude, same altitude as the station, and then it's like a chasing mode, and then we shut down the engine and let it align with the rendezvous and docking procedures, and that they can conduct an easy rendezvous and docking.
Does that need to be very precise as well? Does it have to reach a very precise?
What we call insertion of the spacecraft, this time is the Wentian into the orbit has to be very precise, because the Wentian itself do not have a very big maneuverabilities in orbit. So it relies on the launch vehicle, at this time Long March 5B, to put it on the right location at the right altitude. So it has to be the same orbit as the station, so that it can then conduct a rendezvous and docking.
Right.
So the Wentian itself is not designed for maneuverabilities. So we have to have a very precise insertion of the orbit.
So it's not designed for maneuverabilities, but I was reading before that the Wentian also has a lot of functions that's the same as the Tianhe, right?
Tianhe has I think it's just part of the station itself. If it's not connected to the Tianhe, it's not going to function well. It has to be a closed cabinet with the life support system on, so the astronauts can attend those experiments. So the similarity is the size itself, and also the rendezvous and docking mechanism. But the Tianhe has many docking and docking modes and locations. Even on the rear, it has a docking for the cargo ship and front, and the lower part has the Shenzhou dockings. So this time it's have a direct docking, and then the Wentian will be moved to the side. So we'll have a sagittal connection afterward.
But it can also be used as a backup for Tianhe in terms of propulsion, navigation functions, right?
Well, I think there are many functionalities on board the missions. The design concept is always what we call a redundancy. You have an emergency in Tianhe, you can move the astronauts to Wentian for life support, for maneuverabilities, and for escape purpose. But fingers crossed, we have a good connections and good functioning station. So those systems would be, we'll call it a redundancy system or backup system instead of just in emergency cases. So this is separation of the
first stage and the payload.
First stage and payload, yes.
You can really hear the applause there. I mean, that is a pretty monumental moment, right, for the rocket launch.
You can see once the separation is conducted, there's a little bit tumbling of the spacecraft. So we have to use some of what we call it attitude control engines to make sure that it has a right attitude and position before it's rendezvous and docking. So this is what we call a successful launch itself. The separation of the launch vehicle with the spacecraft means the launch vehicle has completed its job.
That's right. So now all we're seeing is just the Wentian module itself. And then
the next step would be a deployment of solar panels, I think, to generate solar powers so that can have a sustained electricity on board the mission.
And is that the solar panels, are we seeing that there on the screen?
Yeah, I think on the middle side there's a small solar panel for the spacecraft itself. And then there you can see there's a thinner part. The larger part is for rendezvous and docking. The thinner part is going to be for the robotic arms and the solar panels in the future. So the big solar panel for the station will be on the right side. So in the middle is the solar panel for this mission itself.
And these solar panels will essentially be generating energy for everything that's needed in the Wentian.
Yep.
In the station itself.
In the station. And that's enough for all these experiments that's needed to be conducted there? Just using these solar panels?
Well, the solar panels just, this is just 50%. There's another segment is coming. So the solar panel is very big. It's folded and you cannot see it. But it's once it's deployed, it's larger than the spacecraft itself. It's very big solar panel of 2 rails. And it's very efficient in generating powers, over 30% efficiency.
So earlier you were saying that this is the backup, right? So in case something goes wrong in Tianhe, what would happen in that scenario? All the astronauts would move to the Wentian lab, and then would it be able to detach from the space station? And
they shouldn't detach it, because if you detach it, you don't have a means to come back to Earth. You have to use the capsule in case of emergency. So the first thing, in case of fire or leakage, you have to go to the capsule for emergency cases, to the Shenzhou capsules. So those are the only thing that can come back to Earth. This system is, but if you have a smaller problems like air leakage or a small fire. You can put them out, but you can escape to Wentian for temporary purpose before you go back to repair it. So there's a number of airlocks that you can use to lock yourself inside. But the main escape route is the Shenzhou capsule, and the two segments has to work together. So that, but there's a number of airlocks that you can use to separate the different environments.
Well, speaking of the airlock, Professor Sui, so this airlock is going to be the main entry point, right, for the astronauts leaving the space station to conduct any extravehicular activities. So prior to this, they were using a node on the Tianhe. So how do these two compare then with each other, would you say, in terms of ease and convenience and necessity really for the astronauts with the EVAs?
Well, I think that the Tiangong is the only capsule that can have an airlock, so for EVA purpose. And this Wentian is not designed for EVA performance, but in case of where it's necessary, it can still do this. But once the station is completed, we'll have a dedicated airlock for EVA activities.
But that airlock isn't coming with the Wentian?
It's not coming with the Wentian.
And that would be with the next lab module then? Or would it
next
be...
lab, no, also not, but with a separate mission that we can have, that there's a docking towards the station that will have a dedicated airlock for EVA purpose. So once the completion of the station is done, we'll have an additional functions to the airlocks. But currently, Tianhe airlock is good for EVA activities. But the future ones will be more roomier and more convenient.
And just before, in preparation for this lab module going up, the cargo spacecraft detached from the space station, right? The Tianzhou 3 cargo ship. So that undocked, and that's to make space for this lab module. So what happens to the cargo ship now?
Well, the cargo ship was basically what we call it, has a free fall burn into the Earth. So cargo. What we call the Tianzhou 2 has been used for many purposes. We have been maneuvering the Tianzhou 2 for rendezvous and docking exercise in preparation for the Wentian mission, and also we have been using robotic arms to maneuver the Tianzhou 2 cargo ship before we abandon them. So there's a separation a week ago, and then once there's a separation is completed, the cargo ship will be designated to drop into the Pacific with no human inhabitants. So we'll have a burn in the atmosphere because the cargo ship is mostly aluminum, and it's once into the Earth atmosphere, it will burn itself up. So it will be disintegrated in the Earth atmosphere.
Would this one be retrieved?
Nope. Nothing will be retrieved. So we have a safe dropping to the unmanned areas. That's all.
So it's not like the astronauts can send anything
Even
back to Earth.
the end of any space object is the best way is to drop it to the unmanned areas, including the station itself. So in the future, once we have these different segments that is not going to be used or abandoned, we'll have to drop it in a controlled manner back to Earth.
So once it's decommissioned, it's just left.
各位领导、专家、同志们，根据长征5号 B 遥3运载火箭飞行数据
According
和
to
北
the
京
flying
航
data
天器
from
飞行
Yao
服务中心
3
监视
and
计算，
the command
空间
center's
站
calculation,
问天时延长
the space
已
station
准确进入
Wentian
预定轨道。
lab
根据
module
飞
has
行任务
entered
评判
into the
准则，
designated
我宣布
orbit, and
此
now
次
I
发射
declare that
取得
this
圆满
flight
成功。
mission has come to a complete success.
在此，
Here,
我代表
on
发射场
behalf
区任务
of
指挥部
the launch
对
site
参加这次任务的所有单位和全体参演测
command
试员
center, I
表
would
示
like to
热
extend
烈祝
our
贺。
sincere
对领
congratulations
导
to
的各
all
位领导
the
和专家
colleagues, and as
表
to
示
the leaders and
衷心感谢。
experts, thank you for your
任务
long-term
发射阶段工
support
作
and
到此
guidance.
结束。
This is
谢谢
the
大家。
end of the launch mission. Thank you.
Well, there you go. That's the official announcement of the successful launch of this Wentian lab module.
文昌报告，发射任务结果宣布完毕。
it is well on its way to the space station. So then, aside from the Wentian, we are expecting another lab module, the Mengtian, later this year, right?
Yes, I think Wentian and Mengtian will be the final stage for the station itself. So this is the greeting.
We're looking at the pictures of at the launch site, and here's
Premier Han Zheng.
authorities. Yep, Vice Premier Han Zheng of just congratulating all the engineers there. A lot of people to congratulate.
Yep.
Maybe they will have a U-turn to the second row.
I mean, all of the missions so far have been a success for China to complete the space station.
So far, yes. So far, it's very good. So we're in the right path. We had a hiccup with the Long March 5 at the first time, so that delayed this program for more or less. But we had been intensifying this launch to catch up this progress. Yes.
So still on schedule, even with that slight delay.
It's still on schedule. We're planning to finish 2022, and it's still on. So the International Space Station is due to complete 2024. And the members country will have to decide on its future, either separation or commercialization or privatizations. But the only government-owned.
And with that, we're going to wrap it up for this evening. China successfully launches their next module for the Chinese space station, and it is up on its way. If they do have live coverage of docking, we'll bring that to you. If not, we'll bring you a TLP space news update to bring you up to date on the docking and how that all went. If it was your first time here, though, welcome. My name's Zach. I'm the founder and host here at the Launchpad. Here at TLP, it's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together, and this was our live launch coverage of the Long March 5B, launching from the Wenchang Space Launch Center with the Wentian module, and that's going to do it for us here today. If you haven't yet, make sure you engage that subscribe button so you never miss another live launch coverage, space briefing, space news update, or exclusive one-on-one interview. Our entire TLP team is heading down to Florida to bring you full launch coverage of Artemis 1, and we hope to might cut off there. And if you haven't yet, follow us over on our Discord, Twitter, and check out the TLP shop to get 10% off of everything on the shop, because it is launch day. Use promo code LAUNCHDAY. But that's going to do it for us here tonight. This is Zach from TLP Network Studios signing off. I'll see you next time. Bye-bye.